fast and full of momentum. Flight 10's success is still fresh, yet the next mission is already approaching. When will it launch, and what new challenges will SpaceX take on? Meanwhile, SpaceX has reached a major milestone toward true reusability, while New Shepard faces yet another indefinite delay. Many of us are still captivated by the remarkable success of SpaceX's Flight 10. It was a mission where nearly everything went right with only minor issues, and it firmly set the stage for what comes next. The next chapter is Flight 11, the final mission of the Starship V2 series. The question now is, when will it launch and what to expect? According to a recent update from Musk on X, SpaceX is targeting a cadence of one mission every 2 months. If that schedule holds, Flight 11 will likely take place in the second half of October. This pace is both realistic and strategic. An October launch would keep the rhythm steady, paving the way for Flight 12, the first of the V3 series, in December. That milestone would not only maintain momentum, but also fulfill the anticipation of many eager to see the next generation of Starship take flight. However, while that may be Musk's broader estimate, the current pace of preparation suggests that Flight 11 could potentially fly earlier than October. Let us take a closer look at the progress so far. Both the booster, designated B-17, and the ship S-38 have already completed cryogenic testing. Some observers even speculate that B-15, an earlier booster, could be assigned to this flight. Either way, the hardware seems well on track. At this stage, only a static fire test remains before moving to the next steps. B-15 still has its engines in place, with perhaps a few replacements required, while B-17 may already have received its full set of engines during recent work. Meanwhile, engines have been transported to Mega Bay 2, where preparations for S-38 are clearly advancing. In fact, as of the morning of August 27th, S-38 has received its second aft flap, a key milestone that indicates it is ready for further testing. All of this shows that the hardware itself is approaching flight readiness. Yet there is another crucial element, the launch pad. Flight 10 was a vigorous and demanding test, and the orbital launch mount has undergone significant strain. Systems such as the booster quick disconnect and the ship quick disconnect appear to have been impacted by the previous launch. Refurbishment work is now underway, and it is expected to take about a week before the pad is fully operational again. Once refurbishment is complete, the booster will likely be rolled out to the pad for testing. Afterward, it'll be returned to the production site for additional work, including the installation of the flight termination system and the hot staging adapter. At the same time, the ship's test stand and quick disconnect arm will be reinstalled on the orbital launch mount, clearing the way for static fire tests of S-38. The ship could undergo 1 or 2 of these firings. If everything runs smoothly, it'll be returned to Mega Bay 2 for its final checkouts and for the installation of its payload and safety systems. All of these steps suggest a timeline of roughly 1 month. If SpaceX continues to move at this pace, it's not out of the question that Flight 11 could launch as early as late September. That would mean back-to-back launches, something SpaceX has already shown is capable of achieving, and something they might have done with Flight 10 had the S-36 incident not caused delays. Still, it may be wiser to temper expectations. SpaceX has only just achieved a major milestone with Flight 10 after months of anticipation and preparation. It wouldn't be surprising if the company opts for a slightly more cautious approach, ensuring every detail is fully prepared before committing to launch. For this reason, an early October launch seems more realistic, balancing speed with reliability. What do you think? Do you expect SpaceX to accelerate preparations and surprise us with a September launch, or do you agree that October is more likely? Share your predictions in the comments and even take a shot at guessing the exact date. Don't forget to like the video and subscribe to our channel so you can continue to follow every exciting step of SpaceX's incredible journey. Now, not only is the launch date drawing significant attention, but also the tasks assigned to Flight 11 are nothing short of formidable. After the triumph of Flight 10, many expect the objectives for this upcoming mission to become even more ambitious and challenging. SpaceX has demonstrated that the Starship program can advance rapidly, and now the company seems ready to push the limits further. For the Super Heavy booster, one of the key areas of testing will likely involve adjusting the angle of attack. By modifying this parameter, engineers can optimize fuel efficiency and gather valuable data on aerodynamic performance. However, before these refinements can be perfected, SpaceX must address one lingering issue: the engine failure problem. During Flight 10, one of the engines in the central ring failed completely shortly after liftoff. Although the booster still delivered a successful performance, any loss of thrust creates unnecessary risk, which is why solving this issue will be a top priority. Alongside these improvements, other successes from Flight 10 will be further tested and validated. The active flip maneuver and the two-engine landing burn are expected to be repeated, giving SpaceX more confidence in these critical procedures. Another area of focus is the final descent of Super Heavy. In Flight 10, the booster impacted the water too violently, leading to its destruction. This time, engineers will likely refine the landing sequence to achieve a softer, more controlled splashdown, with the ultimate goal of preserving the booster long enough to gather additional post-flight data. As for the Starship itself, the journey begins with ascent. While Flight 10 marked a successful climb into space, the previous 3 flights were plagued with issues that cannot be overlooked. SpaceX will undoubtedly analyze those failures to ensure they do not reappear. Consistency during ascent will be crucial for proving Starship's reliability. Once in space, the next challenge will involve payload deployment. Flight 10 showcased a rudimentary version of this process by releasing small test payloads in a suborbital trajectory. For Flight 11, expectations are higher. Many predict that Starship will not only carry more payloads, but will also release them from a true orbital position. Such a step would bring the spacecraft much closer to its operational role of delivering satellites, cargo, and eventually humans to orbit. Another critical milestone will be the in-orbit relight of Starship's engines. This capability was tested during Flight 10, but for Flight 11, the burn duration may be extended to simulate more demanding mission profiles. If Starship can reliably restart its engines in space, it'll prove its potential for long-duration missions, including journeys to the Moon and Mars. Following orbital operations, the most dangerous phase of the mission will arrive: re-entry. Flight 10 revealed that the heat shield requires further attention. The tiles developed an orange coating due to oxidation, which suggests that improvements in materials or design are still needed. In addition, the aft flaps endured significant stress during the fiery plunge back to Earth, so their protection must also be reinforced. Addressing these weaknesses will be essential to ensure Starship can one day carry humans safely through re-entry. Landing will again be attempted in the ocean. Although Musk has stated that a true landing attempt may not occur until Flight 13, the interim ocean landings are far from wasted efforts. These tests give SpaceX more chances to refine flip maneuvers, deceleration burns, and final contact with the water. Ideally, Flight 11 will see Starship remain intact on the surface for longer than Flight 10, allowing engineers to gather even more recovery data. These expectations set the stage for another exciting mission. SpaceX is steadily turning experimental tests into repeatable successes, and each flight brings the program closer to operational status. While some may be disappointed by the continued use of ocean landings, these steps are deliberate and necessary to reach the ultimate goal of rapid and complete reusability. In other impressive updates, SpaceX continues to reach impressive milestones with Falcon 9. On August 27th at 7:10 a.m. Eastern, a Falcon 9 launched from SLC-40, carrying and successfully deploying a new batch of Starlink satellites into orbit. The booster, B-1095, was only on its second flight, yet it executed stage separation flawlessly, just 2.5 minutes after liftoff. 6 minutes later, it performed a successful landing burn and touchdown smoothly on the drone ship. Just read the instructions. The mission marked a historic achievement, SpaceX's 400th successful drone ship landing. The very first took place in April of 2016 during NASA's CRS-8 mission to the International Space Station, when the booster landed on Of Course I Still Love You. Since then, SpaceX has expanded its fleet with a shortfall of gravitas and has turned drone ship landings into a weekly occurrence. What makes this feat even more remarkable is how difficult it is. Landing on solid ground is already a complex task that few organizations have mastered, but landing on a moving ocean platform raises the difficulty to another level. Despite this, SpaceX has made it routine, while many competitors have yet to even attempt it successfully. Blue Origin once planned a similar method for New Glenn, but their first attempt failed. Some Chinese startups are pursuing the idea, but no significant progress has been made. That is why SpaceX's achievement stands out. Reaching 400 drone ship landings is not just a number, it's evidence of a reusable rocket system operating at scale. To date, no other company has come close. In addition, this mission represented SpaceX's 108th launch of 2025. With 4 months still remaining in the year, they are on track to potentially surpassing 170 launches, a milestone that seemed impossible just a few years ago. As SpaceX continues to raise the bar in both Starship development and Falcon 9 reusability, the aerospace world can only watch in awe. Flight 11 is shaping up to be another historic step forward, while Falcon 9 continues to solidify its place as the backbone of modern spaceflight. The future holds even greater milestones, and the pace shows no sign of slowing down. While SpaceX pushes forward, Blue Origin continues to struggle with delays. The new Shepard NS-35 mission, first set for August 23rd, was postponed by booster avionics issues. A new date of August 26th was announced, but the launch was once again called off. Blue Origin stated on X, "We're standing down on today's NS-35 launch attempt to troubleshoot an issue with the booster's avionics. We're determining the next launch opportunity." This confirms the core issue remains unresolved. Such failures are serious, as avionics problems can lead to loss of control or even vehicle destruction. The new launch date is uncertain. It may slip to the end of August or even September. This only highlights New Shepard's continued reliability problems. Already limited compared to orbital rockets, the system cannot afford such setbacks. NS-35 is meant to carry the company's 200th payload above the Kármán line, including student and university-led experiments from Launch Site 1 in West Texas. Beyond New Shepard, New Glenn faces its own delays. More than 8 months have passed since its debut, and while the next flight is set for September 29th, visible progress has been minimal. Aside from stage and forward module tests in July, no booster rollouts or major milestones have been seen. Oddly, Blue Origin has even tested a second stage intended for the third flight, but this does little to accelerate the upcoming launch. For Blue Origin, time is slipping away. The question remains, how will the company overcome these delays and bring its systems back on track? Why is the current race to the moon so intense? This time, humanity is not merely aiming for a brief visit. The objective is to establish a permanent base on the lunar surface. NASA, China, and Russia each have their own strategies to achieve this ambitious goal. In this competition, SpaceX has unveiled a bold and innovative concept designed to build a moon base both quickly and efficiently. If successful, this approach could give the US and NASA a decisive edge over their rivals. So, how does SpaceX intend to construct a base on the moon, and just how remarkable is this solution? In the upcoming race to the moon, there is more at stake than simply sending people there first. The ability to build a base before others will also play a decisive role in determining victory. Whoever establishes a permanent foothold first will gain an immense strategic advantage in exploration, research, and even future resource utilization. NASA is currently well known for its Lunar Gateway project, an ambitious space station that will orbit the moon and serve as a staging point for missions to the lunar surface. This project is being developed in cooperation with multiple international partners. However, despite its vision, the Lunar Gateway faces significant challenges related to cost, engineering complexity, and compatibility among the various systems contributed by different countries. In addition to the Gateway, NASA has also plans for a surface installation called Artemis Base Camp. This base will be built on Earth, transported in sections aboard rockets, and then assembled on the moon's surface. On the other side of the competition, China has partnered with Russia and other nations to pursue their own lunar ambition, the International Lunar Research Station, or ILRS. Their strategy focuses on using in situ resource utilization, which means they aim to construct their base directly on the moon using lunar materials. The proposed methods include 3D printing structures from mined lunar regolith or melting lunar soil to form bricks. Another possibility is compacting and shaping the soil to create protective structures. These are ambitious and creative ideas, but each approach faces significant drawbacks. NASA's plan, while giving engineers full control over the design and quality of the base, would require many launches to transport all of the components. This would lead to high costs and long timelines. China's approach would require delivering and operating extensive mining and processing equipment before any meaningful construction could begin. This would be extremely challenging without any initial temporary base to house crews and equipment safely during the early stages. And then there is SpaceX. As they've done many times before, they are offering a radically different and potentially game-changing concept. SpaceX's proposal is called Moon Base Alpha, and it revolves around using the Starship HLS, or Human Landing System, as the base itself. The idea is simple in theory, yet bold in execution. After landing on the moon, the Starship would then be repositioned from its vertical landing orientation into a horizontal position, station, where it would serve as a fully equipped lunar habitat. Naturally, the biggest question that comes to mind is how one could safely change the position of such a massive vehicle on the moon without heavy human intervention or specialized support systems. The proposed answer lies in an innovative concept known as the astrostrom mechanism. Here is how it would work. First, lunar rovers would be deployed to prepare the site. They would clear the surrounding area and excavate a trench or hole large enough to accommodate the Starship in its horizontal position. If a natural depression were found nearby, it could be used instead to save time. Next, an inflatable air cushion system would be placed near the landing legs of the Starship, positioned toward the prepared trench. Once in place, the cushion would be inflated, creating a controlled slope. With the help of support systems, the Starship HLS would then slowly and carefully tilt onto the cushion. The purpose of the system is to ensure the vehicle's movement is gradual and gentle, preventing any damage to the structure, equipment, or life support systems inside. Once the Starship is securely resting on the cushion, the air would be released, allowing the cushion to act as a stable lining. The vehicle would then settle fully onto the lunar surface. Finally, rovers would collect and pile lunar soil around the vehicle, forming a protective barrier against radiation, micrometeorites, and temperature extremes. At that point, the Starship would officially serve as the moon base. This method offers several clear advantages. It allows SpaceX to maximize the value and capabilities of the Starship HLS. Starship's size and internal volume make it capable of carrying enormous payloads, but that same pace can also be converted into a comfortable habitat for astronauts. Instead of discarding the vehicle after landing, as is often the case with space missions, this plan transforms it into a permanent and highly functional outpost. From a cost and efficiency standpoint, the benefits are equally compelling. Compared with NASA's multi-launch approach, this method would require fewer launches and eliminate the need to transport large pre-built structures from Earth. And unlike China's plan, it avoids the early requirement of mining and processing lunar materials before establishing a safe, livable base. By using the Starship HLS directly as the base, SpaceX's concept bypasses many of the logistical and engineering hurdles that other approaches face. It is an elegant solution that makes full use of hardware already designed for the mission, while also reducing both risk and expense. If successful, Moonbase Alpha could not only secure the U.S. a lead in the new moon race, but also lay the groundwork for long-term human presence beyond Earth. It would be a significant leap toward humanity's future as a spacefaring civilization. What do you think about SpaceX's idea? If you believe this is the right approach, leave a comment saying, "Let's do it." And remember to like the video and subscribe to our channel to continue following SpaceX's remarkable journey. Not only does SpaceX's moon-based concept excel in terms of construction, but its design also gives it a significant advantage over competing plans. The sheer size of Starship is once again at the forefront of this vision, offering more than enough room to create a versatile, functional, and comfortable habitat. At the start, the Starship Human Landing System, or HLS, is designed with a vertical living arrangement. Multiple floors are stacked within the nose section, optimized for launch and landing. However, once the Starship transitions to a horizontal position to become a base, the interior will be reconfigured accordingly. This will likely involve a flexible design where structural elements such as walls can be rotated or repurposed into floors and ceilings. In its standard configuration, Starship's habitable area is concentrated in the nose cone, while the rest of the vehicle is reserved for propellant tanks, engines, and related systems. Once converted into a base, the large internal volumes previously occupied by these systems could be stripped down and renovated to create additional living and working space. For the current V1 Starship, repurposing these areas could potentially triple the available interior space. Later versions, such as V3, could offer even more capacity. Naturally, such modifications would require significant support from specialized machines and autonomous robotic systems to handle the heavy work in a low-gravity environment. Inside the SpaceX moon base, the layout would follow a logical division of functions to ensure smooth operations and minimal interferences between different activities. One proposed concept features a 6-floor arrangement, each dedicated to a specific role. The first floor would be the infrastructure hub containing the base's energy control center, water, and fuel systems, and a warehouse for essential equipment and tools to support exploration and maintenance. The second floor would be devoted to food production and storage. This area would not only serve to meet the crew's nutritional needs, but also provide a mental health boost, as gardening and food preparation have long been recognized as effective ways to reduce stress and maintain morale in isolated environments. The third floor would house hygiene and fitness facilities. Special low-gravity toilets, compact showers, and advanced exercise equipment similar to those aboard the International Space Station will be included to help astronauts maintain both physical and mental health during long stays. The fourth floor would be the sleeping quarters. This space would be personalized for each crew member, giving them a private area for rest, communication with loved ones, and moments of solitude. The fifth floor would serve as the entertainment and leisure zone. Here, astronauts could read, work on personal projects, and enjoy views of the lunar surface through strategically placed windows. The sixth and final floor will be the dedicated research center, containing laboratories, specialized instruments, and the master control console for the entire base. Critical operations, system monitoring, and mission planning would all take place here. This floor would also serve as the meeting room for important discussions and decision-making. If Starship's internal space is fully optimized, such a moon base could comfortably accommodate dozens of astronauts along with the necessary tools, scientific equipment, and life support infrastructure. This capacity is a clear advantage over the more limited and modular designs proposed by NASA and China. In addition to the internal systems, SpaceX's moon base could be enhanced with external features to improve its functionality and resilience. Solar panel arrays could be deployed around the base to generate power, especially vital for surviving the lunar night, which lasts roughly 2 weeks without sunlight. Robust life support systems, including oxygen generation units and thermal regulation systems, would ensure a stable and safe internal environment. A protective shield of compacted lunar regolith could then be layered over the base. This would provide crucial defense against micrometeorite impacts, debris, and harmful radiation. The choice to establish the base at the moon's south pole, where extreme conditions prevail, makes these protective measures all the more important. The South Pole offers strategic advantages, such as potential access to water ice, but its environment is much harsher than the relatively mild Apollo landing sites of the past. In any high-stakes competition, especially one as challenging as the modern moon race, breakthrough ideas can redefine the trajectory of success. SpaceX's approach, combining the multifunctional adaptability of Starship with efficient construction and expensive interior capacity, represents such a breakthrough. Once again, the innovative leap comes from SpaceX, the company that has consistently redefined the boundaries of modern space exploration. This concept not only bolsters the U.S.'s position in the lunar race, but also sets the stage for a new era of sustainable human presence beyond Earth. Before SpaceX can turn its moon-based vision into reality, it must first meet the challenge of Artemis 3, the mission to return humans to the lunar surface for the first time since Apollo. A successful landing would give the U.S. a decisive advantage in the moon race, securing both prestige and influence. The exploration and discoveries from Artemis 3 will also provide the foundation for building a permanent lunar outpost in the years ahead. Yet, Starship's readiness for such a mission is still uncertain. Many critical milestones for a lunar landing remain unmet. The HLS variant has not yet been fully revealed, and the orbital refueling infrastructure, essential for the journey, has yet to be built. With only 2 years into the planned launch, the schedule is tight. Still, SpaceX and NASA project confidence. SpaceX President Gwynne Shotwell has assured NASA's acting administrator Sean Duffy that Starship will be ready in time. Progress is visible. SpaceX has tested the crew elevator, shared early designs for living quarters, and revealed the airlock's real interior. NASA, after overcoming delays and skepticism, is also moving forward. Both the SLS rocket and Orion spacecraft are advancing toward Artemis 2 and 3, with Artemis 2 set to validate key systems during a crewed lunar flyby. For SpaceX, the year ahead will likely see 3 Starship test flights aimed at clearing earlier objectives. Next year, the plan calls for up to 25 flights, including the upgraded Starship V3 to boost reliability and mission capability. The moon race is shifting quickly, with permanent infrastructure now a core objective. This is no longer about brief visits, but about creating lasting settlements to extend human civilization and prepare for deeper space missions. If SpaceX's Starship can serve as both transport and moon base, it could bypass many of the cost and complexity barriers faced by competing plans, potentially accelerating humanity's expansion beyond Earth. The outcome is uncertain, but the next few years will decide how the future of lunar presence unfolds. Who will win the new race to the moon? The US once seemed the clear favorite, but China's steady progress has shifted that confidence. Many experts now warn China could arrive first. So what must NASA and SpaceX do to stay ahead? The United States secured a decisive victory in the first race to the moon during the last century. That historic achievement continues to resonate even today, not only in technology but also in spirit and confidence. Experience and determination remain two of the most important advantages for the U.S. as it enters a new chapter, one that is not only about returning to the moon, but also about establishing a sustainable human presence there. Yet, while belief in America's ability to lead remains strong, doubts are beginning to grow. These doubts arise when one compares NASA's pace of progress, along with its industry partners, to that of its chief rival, China. The contrast becomes sharper when considering not just timelines but also the strategies each side is pursuing. Dean Cheng, a well-known expert and analyst who has studied China's space program for years, recently shared his insights in an interview. He reviewed China's progress and its methodical preparation for landing humans on the moon, then compared it with NASA's approach. His conclusion was striking. At the rate things are going, sadly, it seems quite likely that the Chinese will land on the moon before NASA can return to the moon. This conclusion is not without reason. It is built on tangible developments that show a growing gap in momentum. Let us first examine the timeline. On paper, the U.S. is ahead. NASA, with the support of SpaceX, has targeted 2027 for its first crewed lunar landing under the Artemis program. China, meanwhile, has publicly stated a goal of landing its astronauts before 2030. By schedule alone, America appears to lead, but the pace of preparation tells a different story. China has made remarkable progress in just the past year, advancing hardware and systems directly tied to its crewed lunar mission. In June, China successfully completed a pad abort test of the Mengzhou spacecraft. This test demonstrated the spacecraft's emergency escape system, a vital safety measure for protecting astronauts in case of a launch failure. Only weeks later, in early August, China carried out a simulated landing test with its Lanyue lunar lander, building confidence in its ability to safely touch down on the moon's surface. Shortly after that, the nation's upcoming lunar rocket, the Long March 10, achieved a full-duration static fire test with 7 YF-100K engines roaring at full power. That successful test was both a literal and symbolic boost to their lunar ambitions. China's efforts extend beyond Earth as well. Over the past decade, it has quietly built the most reliable record of lunar landings in the world. While other nations, including the US, have faced challenges in recent attempts to land on the moon, China has not only succeeded multiple times, but has also expanded its capabilities. It has landed on both the near side and the far side of the moon. It has demonstrated advanced abilities such as sample collection and return, including from the far side, something no other nation has achieved. These milestones show a program that is focused, consistent, and steadily building confidence for the larger leap of landing astronauts. Of course, challenges remain for China. The Long March 10 rocket, for instance, will rely on 3 boosters similar in concept to SpaceX's Falcon Heavy. Their crewed lunar mission will actually require 2 Long March 10 launches, a complex operation that demands rigorous testing and reliability. The Mengzhou spacecraft and Lanyue lander must also undergo environmental testing to prove they can withstand the extreme conditions of space and the lunar surface. Crew training and additional mission rehearsals will also be critical. Now let us turn to NASA. The Artemis program officially took its first step with the successful Artemis 1 mission, an uncrewed test flight around the moon, which was completed a few years ago. But that mission was the result of over a decade of work and tens of billions of dollars invested. Progress since then has been slower than hoped. The Artemis 2 mission, originally planned to carry astronauts around the moon, has been delayed until at least 2026 due to problems with the Space Launch System rocket and the Orion spacecraft. Beyond that, there is persistent uncertainty about funding and political support. NASA's history shows that large-scale programs often risk delays or cancellations when political priorities shift. In contrast, China benefits from a centralized approach. Its space program does not rely on shifting budgets or elections. Instead, it operates under long-term strategic plans with consistent government backing. This stability allows it to move forward without the same political turbulence that NASA often faces. When one considers these factors side by side, Cheng's conclusion becomes understandable. On paper, the U.S. is ahead. In reality, China is moving faster with focused momentum, while NASA faces delays and uncertainties. The US still has strengths, including SpaceX's rapid development of the Starship system, which will be critical for Artemis. But the gap is narrowing, and the possibility that China could plant its flag on the moon before NASA returns is no longer unthinkable. This is why the new lunar race is so compelling. It's not only about technology, but also about strategy, consistency, and the ability to adapt. The US has the legacy of Apollo and the unmatched innovation of private industry. China has the advantage of discipline, stability, and steady progress. Which of these approaches will reach the moon first may define the next great chapter in space exploration. Meanwhile, NASA's partners and contractors have not shown much convincing progress, and this has raised doubts about whether the US can keep its lead in the current moon race. SpaceX, for example, is currently under the most scrutiny since it carries the most urgent responsibility and holds the key role in enabling Artemis 3. The company's Starship is often praised for its ambitious design and potential, but the reality is that the vehicle has yet to complete even a full successful orbital flight. To this day, Starship has not reached orbit in a fully controlled manner, and several tests have ended in partial success or outright failure. Many of the tasks that will be absolutely necessary for a crewed lunar mission, such as stable payload deployment, long-duration orbital operations, and precise controlled landings, are not yet proven. The Starship HLS, or Human Landing System, vital for Artemis 3, has yet to launch. Its required orbital refueling system has not been built or tested, leaving SpaceX less than 2 years to deliver a fully operational HLS, prove refueling in orbit, and demonstrate astronaut safety. The challenge is immense under such a short timeline. Blue Origin also lags behind. Its Blue Moon lander exists only as a Mark I cargo version, while the crewed Mark II remains a concept with no clear schedule. Progress is further slowed by New Glenn, which has yet to fly despite years of delays. Recent U.S. robotic lunar lander attempts have only deepened concerns. Fuel leaks, navigation errors, and software failures have plagued missions, with several craft reaching the surface but failing soon after. Compared to China's near-perfect lunar record, the contrast is stark. Other contractors face similar problems. Boeing's space launch system has become a symbol of cost overruns and delays, consuming tens of billions and over a decade for just one launch. Together, these setbacks cast doubt on America's readiness for the next great lunar milestone. China's advantage is not only in hardware but in strategy. Its government, agencies, and companies all work in unison toward one clear goal: landing humans on the moon and building a base. Each mission from the Chang'e program to Long March 10 tests is a deliberate step forward. NASA, by contrast, often lacks consistency. Deadlines slip, priorities shift between the moon and Mars, and political pressures create uncertainty. SpaceX focuses on Mars as the main target, treating the moon as secondary, which weakens urgency in the lunar race. Meanwhile, China has already outlined firm plans for Tianwen-3, aiming to return Mars samples by 2031. NASA's Mars sample return, however, faces delays and rising costs. Experts like Cheng now believe China may land astronauts on the moon before the US does. Starship could change that if it proves itself soon. Do you agree with this warning? Comment yes or no, then don't forget to like the video and subscribe to follow SpaceX's journey into history. The US, led by NASA and SpaceX, is now at a critical juncture where its goals in space must be reconsidered and more clearly defined. Both the moon and Mars should be recognized as equally urgent and important. While humanity reached the moon in the last century, the context of today's race is very different. The focus is no longer on visiting and studying. The goal now is to establish permanent bases, develop resources, and expand sustainable operations. This is why the moon cannot be skipped or considered a step already completed. Beating China in this new lunar race also carries significant weight for national pride and global leadership. At the same time, Mars represents a separate but equally vital ambition. It symbolizes humanity's transition into a truly multiplanetary civilization. Establishing a human presence on Mars will create an outpost for deep space exploration and secure a new frontier for human progress. In this race as well, it is important for the US to stay ahead of China. Both destinations, the Moon and Mars, matter for different reasons, and both require unwavering focus and determination. To achieve this, NASA and its partners must adopt a sharper and more disciplined strategy. They cannot allow progress on one goal to interfere with the other. Milestones should be set with greater clarity and accountability, leaving no room for uncertainty. This is especially important because progress builds confidence both within the space industry and among the public. SpaceX has shown strong determination when it comes to Mars, largely due to Musk's long-standing commitment to that vision. However, the same focus must now be applied to the Moon. Artemis 3 is on the horizon, and SpaceX must show concrete results soon, ideally before the end of this year and into the next. Encouragingly, there are reasons to be confident. SpaceX President Gwynne Shotwell, along with NASA's interim administrator Sean Duffy, have both recently confirmed that Starship will be ready to support Artemis 3 on the current schedule for 2027. This reassurance comes at a crucial time. With the second half of 2025 already underway, the pace must increase significantly if the U.S. is to remain on track. In terms of resources and potential, the U.S. holds a significant advantage over China. It benefits from unmatched experience, far greater investment capacity, and a powerful network of leading companies that form the backbone of its aerospace sector. These advantages, however, must be fully maximized. Without disciplined execution and sharper focus, even the strongest starting position can be eroded over time. The key lies in aligning strategies, accelerating progress, and maintaining a unified sense of purpose. Another important factor is the need to carefully monitor China's progress. The country has consistently demonstrated that it is a formidable rival. Its steps in recent years reveal not only determination but also an ability to achieve milestones ahead of schedule. No one can fully predict how quickly China may accelerate its timeline, and underestimating its progress would be a dangerous mistake. Keeping a close watch on every move, from spacecraft development to lunar tests, will be essential. The moon race between the US and China is therefore shaping up to be one of the most unpredictable and defining competitions of this century. It is filled with challenges, surprises, and opportunities. The outcome will not only determine which nation places its flag first on new ground, but will also define the course of humanity's future in space. With strong leadership, goals, and the full weight of its industrial power, the U.S. has every opportunity to continue its dominance on the moon and extend that success to Mars. The time to act is now, and the coming years will reveal whether this nation can turn its vast potential into undeniable victory. The wait is over. SpaceX has released the Starship Flight 10 landing footage, revealing the dramatic final moments of the mission. At the same time, SpaceX has set a new reusability record tied to the number 30, while NASA has unveiled the Orion Artemis control room for future lunar missions. After the live stream of Starship's 10th flight, countless clips and images began circulating across the internet, each highlighting different moments of the mission. Yet one particular moment caught nearly everyone's attention: the landing of Ship 37, marked by its striking and unusual white and orange appearance. Viewers immediately wondered whether SpaceX would share high-quality footage of this critical step, and now SpaceX has delivered. The company recently posted 2 videos and 2 images on X, accompanied by the message, "View of Starship landing burn and splashdown on Flight 10, made possible by SpaceX's recovery team." For the first time, we were able to watch the landing sequence from much closer than before, with the speed slowed down just enough to reveal details that had previously been hidden in the blur of rapid motion. In these new videos, S-37 can be seen still in the middle of its flip maneuver. The footage clearly shows the flaps folding forward while the sea-level Raptor engine pivots on its gimbals to adjust direction. These movements gradually reoriented the ship back into a vertical position. This was not just about navigation. The process also slowed the vehicle's descent, allowing it to touch the water in a controlled and deliberate fashion. SpaceX confirmed the details of the test, stating, "Starship made it through re-entry with intentionally missing tiles, completed maneuvers to intentionally stress its flaps, had visible damage to its aft skirt and flaps, and still executed a flip and landing burn that placed it approximately 3 meters from its targeted splashdown point." That last part is especially important. To land a massive spacecraft within just 3 meters of its target splashdown site shows remarkable precision, even when accounting for the intentional stresses and challenges introduced into the test. And then there was the spectacle itself. As S-37 met the ocean surface, enormous plumes of water and vapor burst skyward. The way the light caught the scene, a faint rainbow appeared in the mist, adding an almost poetic beauty to the moment. Against the backdrop of the vast blue ocean and the heavy clouds overhead, it looked less like a test and more like a work of art. Of course, the ultimate goal is not to splash down in the ocean forever. These demonstrations are part of the gradual path toward catching Starship with the Mechazilla arms on the launch tower. Still, every controlled descent and every test of precision lays the groundwork for that ambitious goal. But beyond the landing mechanics, the most talked about detail was the spacecraft's unusual color. The combination of deep orange-red hues, covering most of the ship, paired with the stark white of the nose cone, left many wondering what had happened. Some even remarked that it looked like a miniature Mars with its reddish body capped with white poles. In fact, that analysis was not far from the truth. Musk himself provided an explanation shortly after the footage was released. He confirmed that the orange color is rust from rapid oxidation of metallic test tiles. Essentially, coolant had leaked onto some of the experimental metallic heat shield tiles, causing a reaction that produced iron oxide. This characteristic orange-red coloration is a byproduct of those reactions, and it explains why the phenomenon was absent on earlier flights that did not carry the metallic tiles. SpaceX later clarified the red color is from some metallic test tiles that oxidized. Musk added that the white areas were insulation applied where tiles had been removed, visible on the nose cone and across the ship's body, matching pre-flight images. Fortunately, these effects did not compromise the mission. Musk noted, worth noting that the heat shield tiles almost entirely stayed attached, so the latest upgrades are looking good. This shows the system is improving, however, challenges remain. While tiles stayed in place, oxidation and discoloration suggest the heat shield is not yet ready for full reusability. If large portions must be replaced after each flight, rapid turnaround is lost. For true reusability, tiles must not only survive re-entry but remain flight-ready across multiple missions. The metallic tiles are still experimental, and Flight 10 revealed more work is needed. Adjustments in material composition may reduce oxidation, and while they could one day replace ceramic tiles, for now they remain in testing. Looking ahead, attention turns to S-38 for Flight 11. Early images suggest new refinements in its heat shield, though it remains to be seen whether these changes will fully solve the oxidation issue or simply improve durability. For now, Flight 10 stands as proof of rapid progress. Watching S-37 flip, decelerate, and splash down with precision is a testament to how far the program has advanced in just 10 flights. The question is, will Flight 11 bring even greater progress? If you're ready to see what comes next, comment "Let's do it" and subscribe to follow SpaceX's bold journey toward full reusability. The adventure is only beginning, and every flight takes us closer to the future of exploration. But wait, the heat shield isn't the only critical component that SpaceX is focused on upgrading. Recently, Musk revealed that SpaceX plans to begin attempting to catch the ship, with the Mechazilla arms starting on Flight 13. That means that both Flight 11 and Flight 12, which will also be the very first V3 flight, are expected to still end with splashdowns in the ocean. This will allow SpaceX to dedicate these flights to rigorous testing and to implement stronger upgrades with less risk, preparing the vehicle for the challenges that lie ahead. With the ship itself, we must remember that during Flight 10, one of its engines experienced a slight explosion at the 47th minute of flight. Although this event did not cause critical problems afterward, it highlights the need for reinforcement and improvement. The engines must be made more efficient and more reliable to ensure consistent performance across longer missions. If SpaceX truly wants to send Starship deeper into space, every component of its propulsion system must be built to endure without faltering. Next, there is the protection system for the aft flaps, which are always subjected to intense stress during re-entry. Over the course of recent flights, the aft flaps have consistently been the part most affected by extreme heating and mechanical strain. It's becoming increasingly clear that this area needs a breakthrough in design and material strength. An upgrade in this area will be crucial not only for the safety of the vehicle but also for the reusability that SpaceX aims to perfect. In addition to resolving those issues, other upgrades will need to target even larger challenges. For example, the payload system must be improved to potentially carry heavier and more varied cargo. After all, Starship is designed to be the workhorse for missions to the Moon, Mars, and beyond. Increasing payload capacity while maintaining vehicle safety and efficiency will be a key step forward. Returning to the engines, they must also be enhanced to handle higher performance levels in space. Longer burn times during relight maneuvers will be necessary for orbital insertions, course corrections, and return trajectories. These improvements will help prepare Starship not only for simple test flights but also for orbital missions, eventual landings back at Starbase, and future long-distance journeys beyond Earth. As for Super Heavy, the booster is not exempt from the need for upgrades. One recurring issue has been the complete failure of some engines during flight. This must be addressed to guarantee consistent propulsion efficiency and to support precision landings. The structural integrity of the booster also requires reinforcement, particularly as landing angles are expected to increase in future flights. Testing maneuvers such as active flips or landings with only 2 engines will add even more stress, making it essential for the overall structure to be strengthened ahead of those attempts. So, all eyes are now on SpaceX as we wait to see what kinds of refinements and bold upgrades they will implement for Flight 11 and 12. Each step forward brings the Starship program closer to its ultimate goals. With that being said, let us turn to another milestone that SpaceX has just achieved, a new reusability record. Falcon 9's achievements are so frequent that they have almost become a normal expectation, yet their significance cannot be overlooked. The latest record is especially historic and deserves recognition. At 4:12 in the morning Eastern Standard Time on August 28th, SpaceX launched a Falcon 9 from Launch Complex 39A, carrying 28 satellites into orbit. What makes this mission stand out is the booster reusability record that was set. The booster for this mission, B-1067, successfully landed on the drone ship A Shortfall of Gravitas, marking the very first time an orbital-class rocket has successfully launched and landed 30 times. After the mission, SpaceX proudly declared, Falcon 9 completes the first 30th launch and landing of an orbital-class rocket. SpaceX President Gwynne Shotwell added her own words of praise. From learning to land a rocket to flying the same booster 30 times, congrats to the SpaceX team for continuing to make the impossible possible. The milestone of 30 reuses is unprecedented. It represents the culmination of 15 years of progress and innovation, where SpaceX not only learned how to land rockets but also mastered the ability to reuse them on a scale that was once unimaginable. By leveraging both land-based landing zones and autonomous drone ships at sea, SpaceX has built a reusability system that combines flexibility, reliability, and cost-effectiveness. This approach has enabled them to accelerate their launch cadence, reduce costs for customers, and dominate the commercial launch market. At this point, Falcon 9 has become the gold standard of orbital launch vehicles. With this achievement, SpaceX continues to lead the reusability race by a wide margin. Among its fleet, booster B-1067 now stands as the leader. SpaceX has already set a goal of achieving up to 40 launches per booster. That means B-1067 is now only 10 flights away from reaching that target. If no major issues arise, it seems very likely that it'll achieve that mark. This milestone of 30 is worth celebrating, not just for SpaceX, but for the entire space industry, because it demonstrates what is possible when ambition meets engineering innovation. And for our final segment of today's updates, let us move on to another important development, NASA's preparations for the Artemis program. On August 15th, NASA unveiled the new Orion Artemis control room at Johnson Space Center. Called the Mission Evaluation Room, or MER, it features a modern design and will serve as the engineering backbone for Orion operations. MER provides behind-the-scenes analysis of Orion's performance, working alongside the White Flight Control Room, which handles flight operations. Together, they form a two-room system, one to guide the spacecraft, the other to monitor its health. The facility will debut during Artemis II, a 10-day crewed mission around the Moon. Staffed 24/7 across 24 consoles, personnel from NASA, Lockheed Martin, ESA, and Airbus will compare Orion's real-time data against expectations, identify issues, and provide solutions to ensure crew safety. Beyond Artemis II, MER will collect vital data to shape Artemis III and future missions. Trey Perryman, lead for Orion Mission and Integration Systems, noted that while operations fly the spacecraft, MER brings the reach-back expertise of years of design and testing. With this addition, Artemis gains a new layer of safety and reliability. As NASA prepares to send astronauts around and eventually onto the Moon, facilities like MER will be central to ensuring every detail is accounted for. We have just witnessed Starship's most successful flight yet, but was it truly flawless? The answer is no. While the heat shield's discoloration drew attention, another concern emerged, an explosion that disrupted the engine bay. Though this issue may not hinder upcoming steps, it must be addressed to ensure even greater progress. So, what caused this problem, and how will SpaceX resolve it? This time, Ship's journey can only be described as a true success, far beyond the expectations of many who had carried doubts after 3 consecutive failures. For the first time, Starship demonstrated a level of reliability and performance that began to silence critics and restore confidence in SpaceX's vision for the future. At the heart of this achievement was the Raptor engine system, which played an absolutely critical role in the mission's success. The engines provided the thrust needed to carry Ship to the proper altitude for payload deployment. They also proved their strength and versatility during the in-space relight, a maneuver that was executed with precision. Following that, they successfully performed the boost back burn and the landing burn, which together enabled navigation control, proper deceleration, and ultimately a safe and controlled landing of the vehicle. This was a tremendous demonstration of progress for SpaceX. Yet this success did not come without moments of tension. Around T plus 47 minutes, observers noticed a sudden flash and what appeared to be a small explosion inside the engine bay. Debris could be seen scattering within the compartment, an alarming sight during an otherwise smooth mission. While the system continued functioning and Ship carried on with its objectives, this incident was clearly unusual and demands closer attention. The engines had been performing extremely well up until that point, which raises the question, what exactly happened? There are several possible explanations for such an event. One theory is that the issue may have been caused by an external factor. During hypersonic flight, even the smallest foreign object can cause serious damage to a sensitive system. The engine bay, packed with plumbing, electronics, and structural supports, is particularly vulnerable to such impacts. Some have speculated that a fragment from a deployed Starlink satellite could have drifted back into the engine section. However, this seems unlikely, as Starlink satellites are robust and not prone to shedding fragile debris in that manner. A more plausible explanation could involve a heat shield tile breaking free during re-entry or fragments from the aft flap, which had already shown signs of stress damage. These components are located closer to the engine bay and thus could more realistically end up interfering with its systems. On the other hand, the evidence may point more strongly to an internal cause. One possibility is that the engine system suffered a fuel leak. Fuel leaks can occur if a vent becomes clogged, leading to unregulated pressure buildup inside the lines. Once that pressure exceeds a certain threshold, the line can rupture, spilling propellant into areas of extreme heat. In such a case, it'd take very little for that leaked fuel to ignite and cause a brief but dangerous explosion. Given that the engine had been firing heavily during ascent, hitting up the entire system, this theory holds some weight. Another possibility involves structural damage caused by vibrations. Rockets are subject to violent shaking during both ascent and re-entry, and even a minor crack or weakness could cause a sudden release of fuel or oxidizer at a vulnerable moment. Combined with the already high thermal environment, such a release could easily ignite. Temperature alone could also have been a factor. During re-entry, Ship experiences intense aerodynamic heating. If any part of the engine system became overheated or if friction sparked in just the wrong place, it could have been enough to trigger a combustion event inside the bay. Each of these scenarios remains plausible, and it's likely that SpaceX engineers are investigating all of them thoroughly to ensure that future flights avoid similar risks. The incident did not derail the mission, but it highlighted just how complex and delicate these systems remain. So which explanation do you think is the most likely? Was it external debris, a fuel leak, structural stress, or pure thermal overload? Or do you see another possibility that might explain the explosion? Let us know your thoughts in the comments, and be sure to like the video and subscribe to our channel so we can continue following SpaceX's remarkable journey together. Looking ahead, the real challenge for SpaceX will be implementing upgrades to address the issue and strengthen overall reliability. The good news is that the company already has a strong basis for confidence. Despite the unexpected issue with the engine bay, the overall performance of the system was impressive. The debris from the small explosion disappeared only minutes after the event, and crucially, the engines continued to function through later mission phases. The landing burn was carried out effectively, proving that the incident did not cause a severe or lasting impact. This resilience shows that the foundation of the design is strong, and with targeted upgrades, future missions can achieve even higher levels of reliability. The first area of focus will almost certainly be the protection of the engines themselves. Raptor 2, while already a highly advanced piece of engineering, is still extremely complex and sensitive. The vacuum variant, in particular, has demonstrated issues in past flights, such as pipes that developed small fires under stress. These components will need reinforcement to prevent similar events from reoccurring. Strengthening the materials and protective barriers around these delicate systems will give them greater resilience under extreme flight conditions. Beyond the engines themselves, support systems must also be enhanced. The cooling system is one of the most important. At present, it plays its main role during the engine chill phase, but in the future, it will need to operate more dynamically throughout the entire flight. A more active and responsive cooling system could mitigate overheating risks during ascent and re-entry. Adding advanced thermal regulation could also help the balance of the temperature difference between internal and external systems, which would reduce the risk of thermal shock during damaging sensitive components. Another area for consideration is a fire suppression system. In the event of a localized fire or small explosion, having an automated mechanism that activates instantly to extinguish the problem could be the difference between a recoverable incident and a catastrophic failure. This type of safeguard would be particularly valuable for the Raptor cluster inside the engine bay, where dozens of pipes and connectors create multiple potential points of failure. The engine bay itself will also need attention. It contains numerous intermediate pipes that connect the tanks to the engines, and any weaknesses in these areas could lead to dangerous leaks. In the past, harmonic vibrations caused by the fuel systems have been linked to failures, so strengthening these connections and mitigating resonance effects will be critical. This would ensure that even under the violent vibrations of launch and re-entry, the system remains stable. Of course, all of these improvements are directed toward the current generation Raptor 2, which will carry Starship through Flight 11. That mission will be the last of the V2 series. After that, the focus will shift toward the highly anticipated Raptor 3, a simplified yet more powerful engine designed to improve reliability. Raptor 3 promises to reduce complexity, making it easier to operate and maintain while delivering greater performance. Still, even with its inherent advantages, it will require robust support systems such as improved cooling and fire suppression to ensure mission success under the harshest conditions. Upgrades will not be limited to the engines. Other critical systems on Starship also demand attention. For example, components such as the aft flaps and heat shield tiles can break away under stress, creating the risk of debris interfering with the engine bay. Reinforcing these elements will not only protect the engines but also improve the overall performance of the vehicle. Stronger flaps will ensure better navigation and controlled landings, while a more durable heat shield will protect the ship during re-entry, both of which are vital for full reusability. Super Heavy performed smoothly on its last flight, but suffered a mid-ring engine failure. Such issues are easier to fix through reinforcement, quality control, and monitoring. Flight 10 was a turning point, yet only the beginning. Flight 11 and the V3 series will expose more weaknesses, driving iterative upgrades. These refinements are not just about perfecting Starship, but about enabling orbital refueling, lunar missions, and eventually Mars. Each step forward brings humanity closer to its next great leap beyond Earth. To better understand that progress, let's take a closer look at the engine system on Flight 10 before the problems appeared. Understanding what SpaceX has already accomplished, what it is refining now, and what lies ahead provides a clearer picture of the path forward. For a long time, many people, myself included, saw the Starship engine layout as complicated, even chaotic. With 33 engines clustered beneath the Super Heavy booster, it seemed difficult to imagine how such a dense arrangement could remain manageable. However, ahead of Flight 10, Elon Musk released an image of the booster's engine system, and it changed many perceptions. The first impression was one of order and precision. The layout was strikingly neat, with the engines carefully arranged in their rings and protective plates installed to shield their tops. The design conveyed a sense of reliability, demonstrating that behind the complexity lay meticulous organization. It was no longer just a forest of engines. It was a system with clear structure and purpose. That purpose is seen in the roles assigned to different engine groups. The outer ring engines, covered by protective plating, do not gimbal. Their role is to provide massive thrust to lift the rocket from the pad. By remaining fixed, they maximize stability and efficiency during ascent. In contrast, the middle ring, and especially the three inner ring engines, have gimbal capability. These engines are not just about thrust. They provide flexibility, steering, and precision control. Most importantly, the three central engines are crucial for navigation and for executing the landing burn. This layered design shows that the Raptor system is more than brute force. It is a carefully orchestrated balance of power and control. This impression of reliability deepened once the flight began. SpaceX released dramatic imagery from beneath the orbital launch mount, showing the ignition of all 33 engines. The view captured the moment the rocket roared to life, unleashing an almost unimaginable torrent of fire and energy. To accompany these visuals, SpaceX proudly declared liftoff of Super Heavy, the most powerful launch vehicle in history, on Starship's 10th flight test. It was no exaggeration. Each Raptor 2 produces 230 tons of thrust, which is slightly less than Saturn V's F1, but with 33 engines, Starship surpasses every rocket in history. Its scalability is the key. Thrust can grow by adding engines, while upgrades like Raptor 3 will boost power, reliability, and ease of use. Flight 12 is set to debut this new system on B-18, now preparing for testing. Future designs may expand to 35 booster engines and 9 vacuum engines on Starship, increasing thrust, redundancy, and deep space capability. Engines remain the most thrilling aspect of Starship's development. The Raptors are the heart of Starship, powerful yet still facing challenges. Flight 10 proved their potential, but upcoming missions with Raptor 3 and more engines will reveal how far SpaceX can push them. Each flight brings Starship closer to becoming not just the most powerful rocket, but a fully reusable one, ready for the Moon, Mars, and beyond. In any case, folks, this has been Kevin with Great SpaceX. Don't forget to like the video and subscribe if you haven't already to stay up to date with yours truly on the latest milestones in SpaceX's journey. Thank you so much for watching, and always remember, curiosity, imagination, and inspiration will follow you so long as you keep looking up.